It's my actually first talk on the stage. I'm an engineer from Google, from Jigsaw. Let me get to my slide.
Wrong way.
Oh, go other way. Yep. I'm Alex Loginov, senior software engineer at Jigsaw, and I'm excited to share with you today the exciting project we are working on. The goal is to significantly improve how we make sense of online deliberations at scale, especially, the project might be relevant for all of you because we all here try to improve online conversations. And the project is called Sensemaking Tools. It's a public, it's an open source library available publicly on GitHub. You can use a QR code or a link to get access to it. And we leverage LLMs to get ability for facilitators of large-scale conversations to get a sense of the big volume of input data of different statements that they collect during the public forums, and then they can get the insights, categorize data, summarize in just a matter of minutes, something that wasn't possible just a few years ago without LLMs. For that, we implemented and tested this library with Gemini and Vertex AI, but we built it for flexibility. So really, you can use any LLM like Claude or Llama or any other cloud development. I think I pressed something by mistake. Yeah. So I'll show you the main components of the library, and I also want to share some challenges that we faced and how we address them. There's 3 main components in the library, and the first up is topic identification, where we analyze the input data, all the statements, and try to come up with the areas of what people were talking about. The second one is statement categorization, when we take the identified topics and we create, we sort the statements in the group, in the buckets that go under each of the identified topic. And the last one is summarization, where we actually get those buckets and create summaries of what people were talking about. We highlight the major themes where people agree and disagree, and any actionable insights from those findings. Next one, I wanted to talk about challenges for each of components that we faced. And for topic identification, we started, everyone who worked with LLMs, they see that the non-deterministic nature of LLMs, you can have different outputs for the same input. So what we used is topic stabilization. We basically freeze the set of topics that will be later on used for categorization or summarization, and it helps us to create a stable set that can be used. For example, for channeling the statement, if we have different pillars during deliberation, we can channel those statements to those facilitators. And here you can see a simple example of the library output, where the input was the set of like a large volume of statements, and the output is a stabilized topic that we're going to use for the next tasks. So the next key component is statement categorization, And here, the challenge for us was that current LLMs have a relatively small output token window, so it's really impossible to categorize all the statements at once. So what we come up with the batches when we split the input data into batches of 100 comments and then repeat the process. And with that, while it improves, while help us to categorize all the statements, it's also added some some latency. And how we tackle that, we use parallelization to improve the speed. And the next challenge was inconsistent categorization, where we added some checks to make sure that all the statements were categorized and no additional topic was created, and so on. So here you can see, on the next slide, you can see the output for the categorization. And we got the identified topics and sorted all the statements under them. So now let's dive into summarization, where we face the most challenges. First, the goal of summaries is to get a digestible piece of information. And for that, we were thinking how we can break down the big wall of text into something digestible. And we decided to reuse our identified topics and create like small summaries for them based on the topics. And to add actionable insights, we leverage in group consensus, where we identify opinion groups based on either the statement itself or the voting patterns. And then we use those opinion groups to come up with the areas of agreement or areas of disagreement. It can help with a good narrative, but also it can be actionable thing for facilitators. For high consensus, basically a to-do list, what you can start working on. And for areas of disagreement, it's maybe something you might worth looking into that. Yeah, we also found that adding some statistics very important to make it quantifiable. Like we added how many comments were under this topic, and then we rank all the topics accordingly. So we're injecting those stats for facilitators to easier get a sense of what the areas were most discussed. And the biggest challenge for us was hallucination, actually, where we knew that we wanted to ground the statements into the ground the summary into the actual input statements. But how we did it, we did it for the whole summary in a separate call. After we generated the initial summary, we created a different procedure where we ground and try to match them. And we use LLM, which is really not good with doing that. And we figure out the breaking down in small tasks. It's easier for LLM to reduce hallucinations. So now we use small buckets of topics and areas of agreement to do that, and we don't see any hallucination. So we also use iterators to test our summaries. And lastly, I want to show some next steps. This is output of a summary. And lastly, I wanted to show what we're working on next is visualizations that can help interactively and visually reach access to those outputs, so people can see highlights, they can dig deeper into each of the topic and explore the input statements. So excitement to share with you this soon. We are working on it right now. Thank you.